All right, the first learning target in absolute value is A1. I can solve equations with absolute values. So we've looked at solving equations, essentially isolating the variable. A couple of things we have to account for with solving absolute values. The fact that an absolute value can have a positive or a negative on the inside and have it come out to be a positive on the outside. So I'll talk a little bit more in depth about that as I get to examples. For the first part, I want to make sure that I touch on there are different types of solutions here. You'll either have a solution set or no solution when we're talking about equations. So no solution, an absolute value can never be equal to a negative number. So if you have a negative, that means you're going to have no solution. If you end up with a positive, you're going to have a solution set, which means you're going to have two solutions for each one of the problems that you do. Okay, so jumping right in, step by step, three-step process with absolute values. If you notice, see how my absolute value bars are not isolated on this problem? The first thing we need to do is isolate the absolute value and then check to see if there is a solution or if there's no solution. So we have to be careful of that. Then you're going to split the absolute value into a positive and negative version of the equation, and then solve each version as you, and you'll have two solutions to the ones that do have solutions. Okay, so what does that look like? I guess I can leave the steps up so we can see them. What does that look like for us? Well, if I'm going to isolate this absolute value, basically you pretend like the absolute value bars are kind of a variable. I'm covering those up on the video right now. So I have a plus 2 and a times 3. So I would subtract 2. I would get 3 times the absolute value of x minus 4. Oops, that should be an absolute value bar, equals 6. Divide by 3. The absolute value of x minus 4 equals 2. Now, that gives me a positive solution, or a positive value on the right. So I can have a solution set. I'll split this guy into two parts. X minus 4 equals 2. X minus 4 equals negative 2. I'm going to add 4 in both places. So x equals 6 and x equals 2. Now, I promised earlier that I would talk a little bit more about why these things work. Rather than going all the way up to the original equation, I'm just going to go back up to this guy and check my work. If I plug in a 6 here, for x, I get 6 minus 4, which is 2, and the absolute value of 2 is 2, which makes my equation true. On the other hand, if I plug in 2, I would get 2 minus 4, which is negative 2, and then the absolute value of negative 2 is also 2, making my equation true. So that's why I have two solutions, because the inside of the absolute value bars can either come out as positive or negative. Technically, what we're doing at this step when we rewrite this with a negative 2 is looking at it as negative x minus 4 equals 2 and positive x minus 4 equals 2. And then if you divide by negative 2 or negative 1, you would end up with the equation that I wrote here. I usually just skip over this step. Again, this video course is not about being perfectly correct. This video course is about you being able to be successful as a math student. So if that example made sense, this would be a good time to jump into the next couple, pause the video, try those examples out on your own, and then unpause, see how I did it, and then go from here. I will put my solutions out, and then you can check your work. So with this one, this is one of the interesting cases that we have. I subtract 5 from both sides. That's why it's really important to isolate the absolute value first. Absolute value equals a negative number. Can that ever be true? No, so this is no solution. Okay, no solution. And then next one, I put this one on here because the numbers are a little bit ugly, but that's okay. The absolute value of x plus 2 equals 11 fifths. I'm going to split my equation. X plus 2 equals 11 fifths. X plus 2 equals negative 11 fifths. Subtract 2, which is the same as subtracting 10 fifths. minus 2 minus 10 fifths. That gives me x equals 1/5, or x equals negative 21 fifths. Okay, so those are my two solutions on the last one. Just because they're a little bit ugly doesn't mean they are bad in and of themselves. So hopefully that's helpful in dealing with solving inequalities. Solving the following absolute value equations, not inequalities. I will change that from the video. Thanks.